Well, cross-validation is a procedure for evaluating the quality of an algorithm on a data set. Nested cross-validation is for tuning parameters. So it's the most popular way to tune parameters of an algorithm. And to do it, you need a data set, you need an algorithm, you need an evaluation measure for the quality of the results, and then you need some parameter that you want to tune. And the parameter here, I'm just going to call it k, but it just depends on the algorithm. And for this example, I want to consider 5 different possible values for k. And those values happen to be 1, 10, 100, 1,000, and 10,000. So you can actually sweep the model parameters, so I'll tell you about that shortly. OK, so the way that nested cross-validation works is that you're going to save one fold as the test fold, and then within the training set, you're going to divide the training set into 2 parts, sort of a nested training set and a validation set. And we're going to rotate the validation set among these inner folds in the training set, and then we'll choose the value of k with the highest average validation performance. OK, so here we rotate this validation fold among these folds, and then we'll choose the k with the highest performance. All right, so let me give you the full set of instructions. You divide the data into 10 folds. We reserve 1 for test. And then we take the training set and reserve one of the 9 training folds for validation. And then for each value of k that we're considering, we train using our sort of nested training set, which is the remaining 8 folds. And then you evaluate it on the validation fold. So we now have 5 measurements, one for each k. And then you repeat the procedure 9 times by rotating which training fold is the validation fold. So you now have how many measurements? You've got 9 folds times 5 values of k measurements. And so you end up choosing the k that minimizes the average training error over the 9 folds. And you use that k on the test set. And then, of course, you're going to repeat everything 10 times from this step onward, using each fold in turn as the test fold. And then in the end, you report the mean and standard deviation of the evaluation measure over those 10 test folds. OK, so this is a nice, happy evaluation procedure. The algorithm that performed the best is the one with the best average out-of-sample performance across those 10 test folds, where you perform nested cross-validation 10 times, 1 for each training set. Now, again, if you want to, you could compute significance test set performance across folds. And this whole procedure, this might be computationally expensive because you have to do an absolute ton of evaluations. You have to do 10 test sets times 10 validation sets times the number of parameter settings that we're willing to consider. So it's actually quite a lot of churning there for the algorithm. But this is the way that we generally do parameter tuning and evaluation. We use nested cross-validation for tuning the parameters within the cross-validation.